Here we are going to model of an RLC circuit. You can see at the front of you an RLC circuit, the modeling of an RLC circuit we are going to discuss. And here you can see the circuit at the front of you where the two loops we have seen at the front of us, and the current I1 is flowing through the loop 1, I2 from the loop 2. And we can use two types of analysis to solve this circuit. First one is the nodal analysis and other one is the mesh analysis. And here we are going to discuss the modeling of the circuit through the loop analysis or the mesh analysis, we can say. And we are going to first determine the first equation of the system. And first we have to observe what component we have used in the circuit is the we have given the battery source E, and resistance R1, resistance R2, the capacitor C, and the inductor L. And first of all, we are going to write the equation of the first loop I1, and here if you observe carefully that it is the source of the voltage, and the current is flowing in this direction. And here we can write the E is the EMF or the voltage given by the battery and the source, and it is flowing through the R1. And we are going to discuss the current flowing through R1, and as it is in from positive battery source from R1, we can write it like it current I1 from R1. And now it's flowing through the capacitor C, and we can observe carefully that the capacitor is in a share between two loops, I1 and I2, and both currents are flowing through this capacitor. So the capacitor has two types of the current, I1 and I2 is flowing from this direction. And now if we're going to write the equation of the that the current of the capacitor can be observed here is the 1 over C integral of the current and dt is the current. And in this case the two types of recurrents are flowing through it. If we look it carefully, we are giving analysis of the loop 1, and here we are going to place the same analysis, I1 minus I2 and dt, and it is the equation of the loop 1 of the circuit we have here. The equation is equal to 0. We are now going to discuss about the loop 2 of the current. We have seen the resistance R2 is same like this resistance I2, and R2 flowing through it with the negative sign. And the second one is inductor, and we can see it minus sign over here, L and di2 over dt. And now the third one is the same as the capacitor, and 1 over C and integral I2 will become first because we are taking in consideration the second loop this time, and I1 and the dt is equal to 0. And these both are the equations for the modeling of the system we have seen at upward of the circuit, and this was easy type of modeling of the system. And now we will move forward for the complex systems. In the next video I will share all those complex systems what are now video, and I'm going to start it from the basic. And please subscribe our channel so that we can share more and more knowledge all over the world. Okay. Thanks.